So this is binary tree maximum path sum. This is Leetcode problem 124. So you're given a binary tree, which is a sequence of nodes where each node can have children to its left or its right. And so what we have to do is look at every node on this tree and figure out, going from one node to the next, which has the highest sum in its path. So the optimal path is 2 plus 1 plus 3 with a path sum of 6. In this one, the optimal path is 15 plus 20 plus 7, which will give you 42, because that is the path that will lead you to the highest amount of values in all of those nodes. So we're given this definition of a node, and in the node we can have a left tree node or a right tree node. We're also storing the value. So when we are looking at a tree like this or a graph, and we want to figure out what one node is in comparison to the other nodes in that same tree, what we're really going to have to do is process that root, and at the end we can return the max sum path. So we have to create another method, and we have to process it there. And what this method is going to be doing is it's going to be return the max path for this specific node, right? And in the middle, we can compare it to other nodes we have seen. So this is why we need the other method. So we are going to be returning the max path for this specific node, but in the middle we're going to be comparing it. So we're going to have like a variable that is going to be our max sum path, and the initial value is just going to be the smallest value that is possible for an integer in Java. So we're first starting off, when we are initializing this, we're saying, okay, first it's going to just start up as the lowest number it could possibly be. Then we are going to return that at the end. So this is the first method that gets called. It's going to say process this root. After that's done, it's just going to return this max sum path, and that's all we have to do for our first method. But now we're going to process this, and we're going to call it recursively. So what do we need for our base case? We're going to say if our root is null, we are just going to return 0. So that means we're reaching the end. And now we are going to look at our left. We're going to process that left. I'm going to process the root left. Let's look at our right one. And now let's look at the node here. It's going to be our root value plus our left plus our right. And so here, this is where we're going to say in the middle, we're comparing it to the other nodes we have seen. This is what we're doing right here. I'm just gonna, I guess we can just look here. And we'll say our max sum path is going to be, what is it going to be? Is it going to be the node here, or is it going to be the one that we have seen before? So then at the end, we're going to return the max path for this specific node, right? So we are going to return this root value plus the max of our left or our right. And we're just going to use 0 here. Then this handles the negative values. So it's going to be, if it's a negative value, we're just going to say it's going to be 0. And that should be it. And let's run this. Let's do our test case and make sure it's this 1, 2, 3. So that is correct. It's going to be 1 plus 2 plus 3. And then let's look at this other test case. And that is correct also. And this is going to pass all of the test cases. So again, if you are writing, if you are trying to decide if you're writing a method that you want to compare one node to all the other nodes within a tree, you're going to need 2 methods, and that's going to be to process that tree. So I'm just saying process this root, and then at the end return this maxsum path. The maxsum path is getting updated as it sees a larger path. And that should be it. It's pretty straightforward. Just leave this here if you want to copy the code. And thank you very much.